With a question, a Blackboard game. So in this question, there are integers from 0 to n minus 1 written on a blackboard. So the game goes on like this. In one round, Alice chooses an integer a on the blackboard and erases it. Then Bob chooses an integer b on the blackboard such that a plus b is congruent to 3 mod 4 and erases it. Rounds take place in succession until a player is unable to make a move. The first player who is unable to make a move loses. Determine who wins with optimal play. So basically this question says that there are integers written from 0 to n minus 1 on a blackboard. Okay, and Alice chooses one of these integers first and then erases it. Okay, and then Bob chooses another integer that are left on the blackboard, and that integer should satisfy this condition. Okay, so what is this condition? Let's understand that. So here we can see that we define that x congruent to y mod m whenever x minus y is an integer multiple of m. Okay, so basically this states that if x is congruent to y mod m that says that x minus y is equals to k into m, where k belongs to integer. Okay, to tell if Alice will win or Bob would win. Okay, because as if there are no more integers left that satisfy this condition, Bob would lose, and if there are no more integers left, then Alice would lose. Okay, so let's see the first test case. So the first test case is 2. Okay, so there are 0, 1, n minus 1 integers. From 0 to n minus 1 integers, the board is filled. Okay, because n is 2, right? So in this test case, if Alice picks up 0, then Bob is left with the choice of picking 1. Okay, so let's see if 1 satisfies the condition or not. Condition here is this. As we expand the condition, so a plus b minus 3 would be equal to 4k. Now let's see if 1 satisfies the condition. So a here is what Alice picks and it's 0. We write 0 here, plus b, that is 1 that Bob has picked up, 1, and if we subtract 3 from it, we get 1 minus 3, that is minus 2. Okay, so minus 2 is not a multiple of 4. Okay, as 4 is also integer, right? So minus 2 is not the multiple of 4. You can see there are no more integers left for Bob to pick up, so that he wins the game, right? So Bob loses and Alice wins, so the output is Alice, right? Now let's see the next test case. The next n is 4. So we have 4 numbers on the blackboard, that is n is equals to 4, or n is equals to 4. We have 0, 1, 2 and 3. So let's see, if Alice picks up 0, then we have to choose an integer such that 0 plus b minus 3 would be equal to 4k. right, and 4 is an integer. So k is an integer. So if Bob picks 1, then we have seen in the previous test case that we don't get B, right? If we choose 2, let's say 0 plus 2 minus 3 is equals to minus 1, which is also not the of 4. Okay, now let's see the other number, which is 3. So 0 plus 3 minus 3 is equals to 0. And hey, it is an integral multiple of 4. How? When k is equals to 0, we get 0. So it is 3 satisfies the condition, right? So 0 is going to be picked by Alicia and 3 is going to be picked by Bob. Okay, so we get one pair of A and B. So round 1 is done. Now in the round 2, let's say Alicia picked number 2. Okay, so we have to see if 1 satisfies the condition or not. So 2 plus 1 minus 3 is equals to 4k or not. So it is equals to 0 and it is equals to 4k. So the condition is satisfied. So Bob is going to choose 1 and Alicia has chosen 2. Okay, so these A and B also satisfies the condition. So round 1 and 2 has passed, and now there is no more integers left to pick, right? And it's Alicia's turn. So Alicia would not be able to pick any number, so Alicia here loses, right? So this test case, Bob wins. Okay, now let's see another test case here. N is equals to 5. N is equals to 5. Okay, so 0, 1, 2, 3 and 4. Okay, so if Alicia picks 0, we have seen that Bob will pick 3. If Alicia picks 1, then Bob will pick 2, right? As we have seen in the previous test case that with 2, 1 is paired. So if Alicia picks up 1, then Bob is going to pick 2, right? Now Alicia is going to pick this number, and now no integer is left for Bob to pick. So Bob here loses, right? So the output is going to be Alicia, LS. Okay, so when N is equals to 7, so we will have the numbers at N is equals to 7. We are going to have these numbers 0, 1, 2, 3, 4, 5 and 6. Okay, so when Alice chooses 0, Bob chooses 3, and when Alice chooses 1, Bob chooses 2, right? Let's see what happens when Alice chooses 4. Okay, so when Alice chooses 4, let's see if 5 satisfies the condition. 4 plus 5 minus 3 must be equal to 4k, right? And 4 plus 5 is 9, and 9 minus 3 is 6, which is not equal to 4k. So 5 does not satisfy the condition. Let's see if 6 satisfies the condition. So 4 plus 6 minus 3 is equal to 10 minus 3 minus 3, which is equals to 7, right? So this is also not equal to 4k, hence this is also not the choice. So Bob loses and Alice is going to win again. Now let's see if instead of 7 we had n is equals to 8. Okay, is equals to 8. We have numbers 0, 1, 2, 3, 4, 5, 6 and 7. Right. So we saw that when Alice picks 0, Bob will pick 1. When Alice picks 1, Bob picks 2. Right. When Alice picks 4, then what will Bob pick? Right. So 5 is not going to be picked by Bob and 6 is not going to be picked by Bob, as we saw in the previous test case. Right. So let's see if we can pick 7 or not. So 4 plus 7 minus 3 must be equal to 4k, integral multiple of 4. Right. So 4 plus 7, here is 11, and 11 minus 3 we get 8, and 8 is a multiple of 4, so we can pick this. So Bob will be picking 7. Let's see if Alicia picks 5, then what happens? 5 plus 6, so Bob only has a choice to pick 6. 5 plus 6 minus 3 is equals to 11 minus 3 again, which gives us 8. Right, and 8 is also a multiple of 4, hence Bob is going to pick 6. Right, now there are no more integers left for Alicia to pick, so Alice loses. Okay, so Alice is going to lose and Bob is going to win. So in this test, the test case is not given here. So when n is equals to 8, Bob is going to win. Right. So, and let's see this test case. At n is equals to 100, Bob wins. So what are we seeing here now is that if n is equals to multiple of 4, then Bob is going to win. Else Alice wins. Okay, so in this question we only have to check if n is a multiple of 4 or not, and if it is multiple of 4, then Bob is going to win, because as we can see in this test case also, Bob wins, and when n was 100, which is a multiple of 4 into 25, right, so then also Bob won. Right, so Bob is going to win when n is a multiple of 4, else Alice is going to win. Right, so let's see the code for this question. So we have here the function solve, and we have n, we enter n, and if n percentage 4 is equal to 0 and modulus 4 is equal to 0, then Bob is going to win, else Alice is going to win. So I hope you understand the solution of this question, and if you have any doubts, you can write it in the comment section. Thank you.